Hello, and welcome to part 8 in this webinar series on model-based design for DO178C software development. My name is Mike Anthony. I'm an application engineer for the MathWorks. The topic for this particular webinar is verification of the source code. And it's important to denote that what we're talking about is source code, not object code. In other words, verification of the actual text of the .c and .h files. All right, so this is not verification by testing. This is actually verification by static analysis. All right, and if you watched the previous webinar, we talked about polyspace, and polyspace does the same thing. It does verification on the source code itself, and we saw that as far as DO178C is concerned, when you use polyspace, part of what you're doing is you're verifying the source code against a coding standard. All right? And so typically in a DO178C type process, there's a lot of manual reviews that you would have to do of the source code. And so part of that was review for the code against coding standards. And we saw how we could automate that with polyspace. The other aspect of DO178C, and this is all detailed in table A5 if you're familiar with the documents, you have to essentially review the source code for correctness. And so the tool that we're going to talk about in this particular webinar is one of the MathWorks' newest tools called Simulink Code Inspector. And Code Inspector is really designed to satisfy all of the objectives in table A5 that are not otherwise satisfied by polyspace. And so this is aimed at the traditional manual code review process that you would otherwise typically have to do. All right, so the idea is that in a DO178C process, there's some verification that is required to show that the source code essentially properly implements everything that was in the low-level requirements or the detailed design. And in this particular workflow, we're treating the Simulink model as our detailed design. And so what we need to do is review the source code against our detailed design to ensure that everything that was in the design was properly implemented in the source code. And so what Simulink Code Inspector is an independent verification that the code generated by Embedded Coder is correct and that everything that was in the model is properly implemented in the source code. And so that's essentially the idea of Simulink Code Inspector, is to automate your DO178C code reviews. All right, and it's important to note that Simulink Code Inspector, it is developed completely independent of Embedded Coder itself, and so this can be considered an independent verification, and we recognize that that's very, very important. So this is an independent verification to ensure that the generated code traces to and complies with our low-level requirements. Again, that being the Simulink model. Okay, so if you watch the webinar on Embedded Coder, we talked a little bit about Simulink Code Inspector specific to the traceability aspects. And so we're going to see that again, but that's a large part of what Simulink Code Inspector does is it provides this model to code and code to model traceability. However, it's not just about traceability. It actually does quite a bit more than that, in that it actually looks to understand that the implementation of the mathematics in the code is actually correct according to what was in the model. All right, and the way it does that is essentially what Simulink Code Inspector does is it looks at your Simulink model, right, and then it looks at the C source code, which is generated by Embedded Coder, but it takes those as two independent elements. There's the Simulink model and there's the C source code. And it comes up with an intermediate representation of both. So it translates the Simulink model into an intermediate representation. It translates the C source code, the .c and .h files, into an intermediate representation. And then it kind of normalizes those intermediate representations so that it can do a comparison between effectively every operator in the model and every operator in the code. And then it attempts to match those up to ensure that you basically have one-to-one mapping between all of the constructs in the model and all of the operators in the code. And then based on that matching activity, it will output two things. One, the traceability report, which again we looked at in one of the previous webinars if you viewed that, and we'll look at it again very quickly now. The other thing is you get the rest of the code inspection report, which again essentially verifies that everything in the code properly implements the constructs that were in the model. So if we jump right into the tools, it's actually a little bit easier to understand what's really going on here. All right. So I'm going to open up a part of the larger model that we've been working with throughout this whole webinar series. And this is just the camera angle calculation. And the reason I'm constraining it to this is just the smaller the code is, the easier it is to understand what's really going on here. All right. So this is just that atomic subsystem that does the camera angle calculation. All right. So there's a couple things that we have to do. All right. So the first thing is if we look under code, you can see there's this Simulink code inspector. Okay. And we just need to kind of set up basically a small configuration just so Code Inspector understands what it is that it's looking at. So things like, is this the top model in a model reference hierarchy? Do you want it to look at any embedded model references? In this case, we don't have any, so this doesn't matter. And then the next thing is checking the model compatibility. And so you can kick this off from within the Simulink Code Inspector menu, or this is actually implemented as a series of Model Advisor checks. So if you watch the previous webinar on Model Advisor, then you'll be familiar with how we do this. I'll actually start this from within the Model Advisor. So if I open up the Model Advisor, then what we'll see is one of the folders of checks that's included here, because I have Simulink Code Inspector, is the Simulink Code Inspector compatibility checks. And we need to run those basically just to ensure that we haven't used anything in the model that is incompatible with Simulink Code Inspector. All right, and so you can see that these checks are here, and I'm going to run all of them. Okay, and basically what this is looking for is, not every single construct in the Simulink language is currently supported in Code Inspector. And so each release we're supporting more and more of these different constructs. And so this is a folder of checks that we maintain with every release just to ensure that what you're doing in your particular Simulink model is compatible with Simulink Code Inspector. All right, so I want to run all of these. So let me select Run Selected Checks, which is all of the ones in this particular folder. So we can see as he's running, and again, what we want to see is all green check blocks are essentially that our model has completely passed all of our Model Advisor checks, meaning that this particular model is fully compatible with Simulink Code Inspector. So you can see that in this particular case, my model is fully compatible with all of these checks. All right, so this means that I'm not using any constructs in my Simulink model that are incompatible with Simulink Code Inspector. So I just need to make sure that this is the case before I actually run the inspection. All right, so now to run the inspection, I'll go back under Code, Simulink Code Inspector. All right, I haven't generated code, so I'm going to select this checkbox that says Generate Code Before Inspection. And then I'm going to hit this button, Generate and Inspect Code. So the first thing it's going to do, and you can see it working if we look in the base workspace, is it's regenerating code. All right, and this looks just like this section of code looked in the previous webinars if you happen to have viewed those. Again, we're just looking at this one particular subsystem in this case, so it's not going to be as long or complicated as what we've looked at in the previous webinars. All right, and now that the code's completed, now we'll actually start the Simulink Code Inspector verification. All right, and now the code inspection is done, and so you can see we get this report, okay? And let's go through this report really quickly just to understand what all these different sections mean. So remember that Simulink Code Inspector is really trying to do two things. So one, it's looking at traceability, all right? So you can see that one of the first sections here is this model to code verification results and code to model verification results, all right? So the bidirectionality of this is important, okay? So you can see that basically everything is being claimed to be verified, okay? So there's, in this case, 14 model objects that were successfully verified, all right? And then for code to model within the model name underscore init function, there were 8 lines of functional code that were verified. Within the step function, there were 25 lines of code that were successfully verified. All right. We also look at temporary variable usage. So basically making sure that, especially if you have like the reuse block outputs optimization selected, that there's no accidental clashing or we reuse the wrong variable in the wrong way, so on and so forth. So you can actually see that in this case, there's one temporary variable that we were successfully able to verify. All right. So again, traceability. So all 14 model objects were traced. All 40 total lines of code were traced back to the model. All right. And if we scroll down on the traceability, you'll actually see that we actually paste the generated code into here. And when we look at the generated code, you can see that the first column here is lines of code. The second column is the actual code. The third column is the associated model object. And then the fourth column is basically details of the analysis, right? So you can see for all the commented lines of code, Simulink Code Inspector recognizes that this is it's a comment, so it's a non-functional line of code. So if we scroll down, we can actually see a couple lines of code that are functional, right? So here's a line of code that's basically implementing our input image width times 1/2, all right? And so you can see that Simulink Code Inspector saying this line of code is implementing what was in these 2 blocks in our model. All right. And likewise, if we scroll down, you can see that. And it's important to note that the granularity of the traceability is a little bit higher with Simulink Code Inspector than it was just with Embedded Coder, right? Because here you can see that we actually look at more the operator level than just the total functional line of code, if you will, which is what Embedded Coder looks at for traceability, okay? So Simulink Code Inspector, this report is actually much more interesting if something goes wrong, all right? So what we're going to do now is actually change the automatically generated code by hand. So this is a huge no-no, right? This is something that we all recognize, hopefully, that you should never, ever change the generated code by hand. I'm simply doing it for the sake of example so we can understand a little bit better what it is that Simulink Code Inspector is really looking at, all right? And we're going to play with this functional line of code right here. Okay, and so this is the functional line of code that basically implements this sum block and this divide block and this gain block. All right. So the first thing we want to do is let's actually look at the .c file that was generated. All right, because we're gonna, again, huge no-no, but we're gonna do it anyway. We're gonna change this by hand. All right. So if we scroll down to line 63, so this is where that particular functional line of code was implemented. Okay, and you can see that what it's doing is 10 times quantity 1 divided by this RTB underscore angle scaling. This is essentially implementing this line right here in the model, okay? And then you can see we multiply that by the difference of the ball position and that same signal. So that's this sum block and then this signal right here, okay? So what we're going to do is change this line of code. And the first thing we want to do is make a change to it that does not affect the functionality, right? Doesn't change the mathematical validity of this particular line of code. All right, so first I'll get rid of that extra line spacing just so it makes this a little bit easier to see. All right, so you can see that right now we're doing 10 times this quantity times this quantity. So what I'm going to do is I recognize that multiplication, right? It doesn't matter which order you give it the arguments, right? So it's commutative. So what I'm going to do is basically just switch the order that I'm doing the multiplication. So I'm going to take this operation and put it on the left-hand side of the multiplication operator and take this quantity, and I just have to make sure I get my parentheses correct here, and put it on this side of the multiply. All right. So now the generating code, it is different from what Embedded Coder generated as far as the actual syntax. However, mathematically, this is exactly equivalent to what we had before. So now what we're going to do is rerun the verification. So we're not going to regenerate the code because we don't want to overwrite that manual change that I just made, but we want to run the inspection again. And what we're looking for is whether or not Simulink Code Inspector will identify if anything is wrong in the code. All right, so let me run this, and while it's running, we can talk about should Code Inspector find anything wrong with this? And the answer is no, it shouldn't, because we did not affect the traceability of any of the operators in the code or any of the blocks in the model in any way. So it's still fully traceable, and it's still mathematically correct, right? The way this particular line of C code is implemented, we'll get exactly the same answer every time as we would with the generated code that we looked at before. So if we scroll down to this line of code in the report, right, you'll see that first of all, the Simulink Code Inspector, it recognized that change that we made by hand, right? So you can see the order is different, but you'll also see that, again, everything is still fully traceable. We didn't impact traceability at all, right? And mathematically, it's identifying that there's nothing wrong mathematically with this particular line of code. So this is completely acceptable, right? So again, this illustrates the independence of Simulink Code Inspector from Embedded Coder, right? And it hopefully also illustrates a little bit clearer exactly what it is that Code Inspector is doing, right? So if you think about that slide we looked at, when Code Inspector came up with the intermediate representation from the model and that intermediate representation from the code, it was still able to do that 100% mapping between every model object and every operator in the code, right? So it understands that there's absolutely nothing wrong with this, right? And we recognize that because multiplication is commutative, all right? So now the question is, well, what if we make a change to the code that does have a mathematical impact on the model, all right? So let me put this back the way it was before. Again, not that it matters because multiplication is commutative, but so this is what we got out of Embedded Coder. So now let's make a change. Let's change the order to this divide operator, right? Because division is not commutative. So if I change the order left-hand side and right-hand side to the division operator, like so, right? This has changed the mathematics, right? We recognize now that mathematically this is going to give us a different answer than before. All right, so now let's run Simulink Code Inspector again and see what it gives us. All right, so the first thing we can see is right away, Code Inspector saying, hey, I cannot verify this code. This code is not, right, functionally equivalent to this model. And so if we go down, we can try to understand why it is that that happened, okay? So you can see that it's saying there's 2 lines of code that it failed to verify. There's 3 model objects that it failed to verify. All right, there's 2 lines that it failed to trace. So again, if we go down kind of the details here, so you can see in the model to code verification, it's saying that this block failed to verify. It's saying that this divide block failed to verify. All right, and then it tells us where in the code these blocks were implemented. So in this case, it's saying that this model object, the divide block, it was unable to match that to this line in the code. All right. So again, if we scroll down kind of to the bottom here where we paste the code in, we'll be able to see exactly what's going on, right? So it's saying, right, it failed to trace, so it failed to verify this particular line of code. All right. So again, this is just to illustrate what would happen if for some reason the generated code for some reason didn't mathematically match the model. And so the reality of Simulink Code Inspector is that 99.99999% of the time, you're going to get a report out that says everything verified to completion and everything is green and verified and everything's good. Because the reality is the only way that something would ever be wrong is if there was an error in Embedded Coder. So if there was an error during code generation. But that's exactly the purpose of this tool, right? And so that's why typically in a DO178C process, you would have to manually review the generated code because you effectively have to ensure that the code generation tool did not make an error, okay? And so really the purpose of Code Inspector is to do that review for you, all right? So now let's talk a little bit about tool qualification. Okay, so the reason that we would have to review the generated code by hand to make sure that it properly implemented everything that was in the model is if the code generator is not a qualifiable tool, which in the case of the MathWorks tools, Embedded Coder is not a DO178C qualifiable tool. However, Simulink Code Inspector is part of the DO qualification kit. So Simulink Code Inspector is a qualifiable tool. So this follows along with kind of the MathWorks standard thinking with qualifiable tools, which is that rather than trying to qualify Embedded Coder as a Criteria 1 tool, or what used to be called in 178B a development tool, right? Instead, what we want to do is automate the verification of the results of that tool with a qualifiable verification tool or Criteria 3 tool. So if we hop back to our workflow picture, right, that's exactly what we're doing here. We're saying, okay, if Embedded Coder is not a qualifiable tool, that means we have to verify the output of that tool, the source code, by hand. Right? But what Code Inspector does is it says, well, we will automate the verification of the source code against the model using a qualifiable verification tool. So what Code Inspector does, again, it satisfies all of those objectives in Table A5. So it satisfies the fact that we need to review the output of our code generator, right, for correctness. So we're going to do that in an automated way with a qualifiable verification tool, and that is Simulink Code Inspector. So the result of that is that what you get from using Simulink Code Inspector is the same level of automation as you would get if you used a qualified code generator. All right, so using Simulink Code Inspector gives you all of the same benefits as using a qualified code generator, so as if we had qualified Embedded Coder. So that's really it about Code Inspector. Again, the whole purpose of Code Inspector is that Simulink Code Inspector, as part of the DO qualification kit, is a tool that can automate your manual code reviews. Okay, and it can automate those manual code reviews as a qualifiable tool. So again, the real value statement of Simulink Code Inspector is that it allows you to take all of the same credits using Embedded Coder and all the MathWorks code generation tools. It allows you to take all the same credits as using a qualified code generator. Okay, so that is a significant value because, again, anytime that you can automate any sort of manual review process is a huge time and money saver over the course of a program. So being able to use Simulink Code Inspector to automate that part of your manual code review process represents significant value, right? The other thing to recall is that if you watch the previous webinar on Polyspace, so between Polyspace and Simulink Code Inspector, we can actually satisfy all of the objectives of Table A5, which means that using both tools and qualifying both tools, there's actually no need to do any sort of manual review of the generated code. And so that represents a significant value. So hopefully that was a good quick introduction to Simulink Code Inspector. All right, so that's it for source code verification. So the next and last webinar in the series will now look at object code verification. All right, so if you're interested in that, please feel free to view the next section. Otherwise, thank you very much.